we just added the pin, we are going to try and re-experiment. In our previous experiments, we first manually pulled it back, and then shot it. And the second time we didn't, the robot pulled it back, but that was before the pin was there. Now we're going to add the pin so that it will shoot, so that we're hoping that it will be more accurate. I'll go get the ball while you reload.
Good. All right. And now we will start the program. You ready? Alright, it's gonna fire. Right. Are you ready?
Statistically, we want to have more than 30 samples, so we just chose 50. So if you look over here, we've got a dose cluster range closer than our previous experiments. You can see most of them are basically within this range, but it's better to actually calculate where we want to do it.
This technically had a wider ring of area around it. These ones were clustered tighter together, so as you can see, hey, they're just really tightly clustered together.
So I measured them out while you write them down on the whiteboard.
Mm-hmm.
$25 and 5/8.
Wait, what?
25 and 5/8. 625. Since it's in fractions over here, would you mind not just putting fractions?
I'm not sure if I can do that.
Just read out the numbers for him.
25 and 25.25. 25. 25.875. 23.5.
Alright.
20.75. Now that we have our values from the base of the cannon to the markings, we're going to calculate the standard deviation, which the formula is.
I was starting the formula. Alright. You explain.
The standard deviation is equal to the sum of each of these values minus their average, and then squared, and then subtract the amount of these, and divided by the amount of these values subtracted by 1, and take square root of the whole thing. To make things easy, we're just going to take this one step at a time. First, we are going to figure out the average. So 25.625 20. I'll just move over to have more room. 25.625.
Why don't you just use a calculator and add them up right there?
Okay. I'll just use this one.
Oh, I didn't understand. Yeah. Okay, so now we're going to find the average here. And how we're going to find the average is that we're going to add up all of these numbers right here, and then we're going to divide them by the number of how many are here. And then that would give us 1,156.2. Then we would divide that by the number of how many samples we have, which is 48. And that would give us 24.09. How we're going to find the standard deviation is that we're going to take, for example, take 25.625, and then we're going to subtract 24.09, which is the average from it. Then we're going to square it, as you can see here. And then for our next one, we're going to take 25.25, and then we're going to subtract the average from it, and then square it, and then so forth. Alright, we're going to do it that same order until we're finished with all of these samples.
And then we're going to divide it by the number of samples subtracted by 1. The reason why we're subtracting by 1 is because we are doing other tests in the future. In other words, this is a sample out of a larger population.
Next, we will square root it to get 2.19 as our standard deviation.
Now we can always just take one standard deviation, but what we want is 2 standard deviations, which is 95%. once we know the average, which is 24.09, our formula would be 24.09 is equal to, hold on. Our formula to get this left side is 24.09 minus 2 times 2.19. Using rules of PEMDAS, I'll multiply first and then subtract that from it.
So we would get 19.7.
No, that's doing the whole thing.
Oh.
Just using laws of PEMDAS and showing the work.
Alright, so it would be 4.38.
So this is equal to 24.09 minus 4.38, which is equal to
19.71.
Okay, 19.71, which is the part over here. The 95% would actually be over here, would take up this area. That would be all the 95% of where everything lands. So now I'll do the same thing for the right side, which is 24.09 plus 4.38, which is equal to
which is equal to 28.47.
8.47. This is what a normal bell curve looks like, and I created a dots plot, and this is the green is for my newest experiment. If you look at it, it actually it looks like a normal bell curve. That include, we don't know what happened on how we got these values, but we don't know how that happened, but we're just assuming that this is a normal bell curve because it really looks like one. However, on our previous experiment, it did not look like a normal bell curve, but it did have one hump, which led us to this test because we assumed that there was something wrong. Now, to figure out how the diameter of the cup, we would have to subtract 28.47 and 19.71.
That would be 8 inches,
8.76.
8.76.
This would be about 8.8 inches, which is about the required diameter of the cup. In our previous experiment,
This is a lot smaller than our previous experiment because in our previous experiment, it was nearly 18. As you can see, it's over 10 inches smaller than how the diameter needed to be than last time.
so we just were able to make our robot a lot more accurate. That's it.
This This has been our Science Fair project. Thank you for watching.